Hey, this is page 2 of the mole review. Again, looking at the overall answer key, you can check your work. If you have anything wrong or need a little more detailed directions, just go ahead and stay tuned and I'll go through each one of these. If there are still any questions you may have from the first video or this one, feel free to cell me and let me know. Now, in explaining the first two questions, there really no work needed. Basically, the molecular formula is a true formula. What it's actually made of, the atoms involved. Glucose, for example, is actually made up of 6 carbons, 12 hydrogens, and 6 oxygens. That's the molecular formula. The empirical formula is just the reduced formula. So you could see that 6, 12, 6 ratio all have a common factor of 6, so it could be reduced to 1 to 1. And so for 10, that's all we've done. 2 to 2 reduced to 1 to 1. 2 to 4, 1, 1, 2. 3 to 6 is a 1 to 2 ratio. And you can see C and F have a 1 to 2 phosphorus to oxygen ratio, giving them the same empirical formula, though molecularly they are completely different compounds. 2, 1, 3 cannot be reduced because of the 1, so it remains the same. Compound can have the empirical formula being the same as its molecular formula. And we've already seen letter E and F. For question 12, we're starting with moles of different elements. However, this problem may have easily started with grams of each and told you a compound made up of this many grams of carbon, grams of hydrogen, grams of nitrogen, and grams of oxygen. Find the empirical formula. Well, to do that, you would need to convert everything to moles. And you could use the molar mass of each element to do quick conversions before. But that would require extra steps for each of these and would take this problem a little bit longer. Here we've already started in moles, so there's no need to convert. No need for molar masses. But once you have the number of moles of each, it's really important that you see the relationship. For example, how does each of these relate in terms of quantity to the other? Well, to do that, you simply look at these and find the lowest number, and that's this one here, 0.32, and you take that and you divide all of these by that number, and you can see how many times greater each number is compared to the smallest. Well, 4.48 moles of carbon is 14 times greater than the nitrogen contributed. Hydrogen is 18 times greater in quantity by mole. Obviously nitrogen is 1, and oxygen, you can see, is 5 times greater by quantity in moles than nitrogen. So you could see the lowest whole number ratio. For every 14 carbon, there are 18 hydrogen, 1 nitrogen, and 5 oxygen. Now this may not be what the compound truly is made of, but it does show us the relationships by mole of each to the other. Luckily, these all ended up being whole numbers. Had I received any decimal, like 1.5, then you would double everything to make that 1.5 whole. Or a 0.33, you would triple, or 0.25, you would quadruple. In this case, no doubling or tripling or anything was needed. So we just take this and write this as our empirical formula. So a couple of important things here again. If you're not given moles, let's say you're given grams, you have to convert each to moles, and you have a way to convert grams to moles using the molar mass in the periodic table. If you were given percentages, then you would assume that's out of 100% and assume you have 100 grams and just convert those percentages straight to grams and then convert the grams to moles. Alright, question 13. Find the molecular formula. Find the true formula given the reduced formula. Now we know the true molar mass is 92 grams. So here's what we know. We know that the reduced formula is NO2. We're looking for the true formula. Well, we know the true mass is 92 grams. We can easily find the empirical formula mass by just looking at the periodic table, the number for nitrogen times 1, and the mass for oxygen times 2, giving us a total mass of 46.01 grams per mole. So if the reduced version has a molar mass of 46 grams about, and the true version of the compound has a mass of 92 grams, how do these compare? Well, we could easily divide them to see that 92 is 2 times greater than 46, approximately. Therefore, the molecular formula must be 2 times greater than the empirical formula. If the mass is 2 times greater, the formula must be 2 times greater, giving us a formula of N2O4, simply doubling those subscripts. And finally, question 14, percent water in a hydrate. This is from the lab perspective. I started with an empty test tube, added crystal. You can see the mass gained. How much mass was gained? That was 3.03 due to the crystal being added. So that's the mass of just the crystal. You can easily find that by subtracting these two. Now, the crystal and the test tube, before heating, had a mass of 17.50 grams. After heating, you can see water was driven out, and the mass dropped. It dropped by 1.50 grams. Well, the reason it dropped is after heating, that water evaporated. So I know that 1.50 grams was lost due to evaporation of water, and if the total crystal was 3.03 grams, I could find out the percentage of water. 1.50 is the part water over the total crystal of 3.03 times 100. Tells me that 49.5% of the crystal was water. Alright, this concludes part 2. So, like I said earlier, any questions, feel free to sully me. And be ready for a test soon. Thanks for watching.